Once again, welcome back to my dear friends to the Tech Civil Learning. As you know, our channel is continuously insisting with providing the practical education to the students, as it is our motto. So the main motto of our channel is to connect the students to the practical level so that they can understand the concept clearly. So without wasting time, let's start the today topics which is mentioned in the thumbnail. So my dear friends, I promised you, just give me your 20 to 30 minutes time. You will surely going to understand the concept. So let's start without wasting our time. So today we'll especially discuss about the means composite section. We will analyze the bars of the composite sections, means here's composite bar means nothing, a bar which is made up of different materials, a bar which is made up of different materials is referred as the composite bars, in which the bars of different means what we call the bars of different materials of having the same length, it's having the same length which is fixed rigidly at the one end, either it may be in the down or it may be the upward, but it is fixed at one end, and both the bars start behaving like a one unit, means as you can see in the figures, this is this is two bars, the section 1 and sections 2. So this is two different bar, either it may be, suppose assume it is copper or it is what we call aluminium, so these two bars is connected with this top surface rigidly, means it is rigidly fixed to the top surface. So we can say that composite bar is nothing, a bar of different materials, as you can see, the different materials of having the same length, means it is having the same length from the fixed rigid, it is having the same length, if it is L, then it is having the same length, and it start behaving like a one unit, means if the elongation takes place in this ones due to the what we call tensile load, then the equal amount of strains what we call exist in that ones. If the compressions, then the equal amount of compression strain takes place. So we can say that composite sections means nothing, a sections of different materials of having or behaving as a one unit. So now we'll talk about the characteristics of composite bars, means what are the properties possess it, so what happens when the extension and compression means in each bars is equal, in this one what happens, as you can see in the above figure, that means in this ones the compressions as well as what you call extensions is equal, so hence the strain in each bar is equals, means that is sigma in equal to sigma. Here the sigma C means that is copper or sigma A means aluminium. So the strains in the composite bar of having different materials is same. Remember that point, it may help you in solving the numericals, that the strain taking place in the composite bar of different material is same, either it may be the what you call compression or extensions, but it has the same what you call strain. Similarly, the total external load on the composite bar is equal to the sum of the load carried by each different materials. Means suppose imagine this one is composite sections, if it is carried P load, that it is the P load is carried by both the sections, section 1 and 2. This means the P is nothing but the total load, then P is equal to, here P is equal to P1 plus P2, means the total load is equal to the sum of two load, that the sum of two sections which is carried means the total load, that section 1 and section 2. So these are the characteristics we must have to understand or analyze for the further study of what you call the composite section. Let's analyze the composite sections more deeply. So what we have means certain assumptions, that is in sections 1 what I have assumptions, copper, you can assume as you like, and sections 2 I have assumed what, aluminium, means aluminium, it is copper bar and it is aluminium bars. So P is nothing but the total load of the composite bars, means P is the load carried by both the bar, at the same time L is the length of composite bar or length of the two bar. Similarly, here I have divided section 1, that A1 means area of the cross sections bar, E1 means Young's modulus of bar 1, because it is of different bars, so it has different Young's modulus. Similarly, means P1 is the load shared by bar 1. Similarly, means sigma 1 is nothing but the stress induced in the bar 1 due to the load. Similarly, means these are the corresponding means representations of the value, right? A to the area of cross section of bar 2, E to the Young's modulus of bar 2, P2 means load shared by bars 2, and sigma 2 is the stress induced by means what you call bar 2 due to the load. So hope up to means now you have understood the clearly. So let's analyze these bars more clearly so that you can understand. So my dear friends, according to the properties or characteristics of the composite bar, I have told you that the total load equal to the sum of the load carried by both the bar, right? Means sum of the load carried by both the bars means, and I have shown you figures in the above. So we can see that if P is the total load, then means P1 plus P2 means these are the two sections, right? Two sections, as I have divided two sections, P1 plus P2. So we can write it as P1, as you know, sigma 1 is equal to P by A, that is what you call load means shared by section 1, right? Or the load shared by bar 1. Similarly, means these ones, if you need to calculate P1, then sigma 1 into area, right, is corresponding area, then sigma 1 into corresponding area, as you know, means it is very simple. So similarly, means P2 is equal to sigma 2 into means area 2. So ultimately we can say that P is equal to sigma 1 into A1 plus sigma 2 into means A2. So A sigma 1 and sigma 2 are the stress, at the same times A1 and A2 are the area of the cross sections. So according to the means what you call second properties, it is said that the stress induced in the composite sections by the means what you call means different materials, right? Either it may be the aluminium or coppers, the stress induced, or the either it may be the compression strain or the what you call extension strains, either it may be the tensile or compressions, but the stress induced in the composite sections are same. Okay, means it is same because it is fixed at one end rigidly, right? So the extensions taking place in the composite sections, if the extension taking place in the composite sections, then the means it has same extension, right? Both the bar have same extensions. So we can say that E1, that is a strain in means what you call bar 1 equal to a strain in bar 2. So as you know, my dear friend, the strains is nothing but the stress by Young's modulus. Similarly, means E2 by means what you call sigma 2 by E2. So from here we can say that sigma 1 by E1 is equal to sigma 2 by E2. So this is the formula which you need means what you call which you need to be understand for solving the numericals. So my dear friends, both means above these ones, P1 is equal to, that is sum of means load, these two should be considered in mind very clearly to analyze the any type of problem. If you have means the clear cut concept on these two formula, you can solve any numerical based on the composite sections. So it's very easy to analyze the composite sections, and hope you understood very clearly. So let's see. So my dear friends, this equation can be written as means what I did, I just take means sigma 1 by sigma 2 is equal to E1 by E2, and E1 by E2 is also called modular ratio. Sometimes it may be asked multiple questions, means multiple questions, right? Multiple choice questions. So you have to know all these things. So E1 by means E2 is nothing but the Young's modulus of material, Young's modulus value of bar 1 by Young's modulus of bar means value of bar 2 is also known as modular ratio of the first material to the second materials, either it may be the bar 1 or bar 2. So hope means you have clear cut concept on these means what you call composite sections. So if you understand these composite sections very clearly, the property or characteristics which I have mentioned, so you can solve any type of numerical based on the composite sections very clearly. So no need to worry about this one, just we have to analyze the numericals very clearly. So let's see some of the numericals so that it enhance your knowledge and you can understand the concept very clearly. So my dear friends, this is very interesting or very practical type of numericals questions for the civil engineers. As you can see, a concrete column of cross sections area, you have given the means what you call cross section area of column, that is 400 mm by 400 mm, right? This is, if this is column, then its width means what you call width and depth is 400, for means it is a square type of column, right? It is a square type of columns, is reinforced by 4 longitudinal bar, right? Means in the concrete it is reinforced with a steel bar of having diameter 50 mm, right? The round steel placed each means, and the diameter is and the reinforcement is placed at the corner of each what you call corner of the means what you call column. So if the column carries compressive load of the 300 kilonewtons, as you know column is a compressive member, so it must carry compressive load as a 300 kilonewtons, means the total compressive load carried by column is 300. So calculate the load carried, of separately the what you call concrete or separately steel. Similarly compressive stress we have to calculate, which is produced in the concrete and the steel bar separately. So here the Young's modulus of the steel is given 15 times of that concrete. So it's very easy problem. We have to calculate the load of the different sections, means load of the shed, that is what you call concrete and the steel. Similarly the stress induced in concrete and steel. So we have to calculate all these things, and it is very relevant to our practical life. So let's understand the concept. Here I have told you, my dear friends, in the composite sections we just have to focus on these two concepts, right? You just have to focus on these two concepts, that is total load is equal to sum of two loads, and the strain, that is the change in, or a change in extensions or compressions, is one section is equal to another sections. So just we have to analyze, we have to understand these two steps, and you can solve any numerical. So here what I did, area of the column is given, cross section of the column is given. So from that ones I can easily calculate the area of column. So 400, it is in mm, as it's depend upon you whether you can take in mm, or whether you can take it centimeters, or whether you can do it in meters. So what I have did, I have just converted the mm unit into meter. So for converting mm into meters we have to divide by 1000. So 400 divided by 1000, right? So 400 divided by 1000. So 0.4 into 0.4, 0.16 meter square is the area of column, right? Means this total column of area is having 0.16 meter squares. As you can see, I have reinforced bar of the columns of the corners of having 50 mm diameters. So here we can, now we have already calculated the area of the column. Now we will calculate the area of steel. So because steel is reinforced in the column, so steel diameter is 50 mm. So I have converted 50 divided by 1000, that is 0.05 pi by 4 d square formula. So we have calculated the area of column. Similarly we have calculated the area of a steel bar. Now we need to calculate the area of concrete, because here the two sections is concrete and steel. Remember, steel and concrete are the two different composite materials. So we have to know the area of these two sections very clearly. So for calculating the area of concrete, in this one, if this one is the area of column, then we will subtract the area of reinforcement, then ultimately we will get the area of concrete. So by these ones, that is the total area of column minus area of steel. So we will get the area of concrete is nothing but the 0.1521 meter square is the area of concrete. So my dear friends, as you know, as per our properties of the what we call composite section, so I have told you that a strain in what we call a steel bar is equal to a strain in concrete. So according to the what we call properties of the composite section. So here the what we call a strain in a steel bar is, that is a strain a small e, that is small e can be written as sigma s by Young's modulus. Yes, similarly the strain in concrete is sigma c by ec. So from here either you can what we call you can make equations either in the form of ec or in the form of es. So here what I did, in the form of es is equal to ec into es by ec. I have just what you call shift this es in this side. So here es by ec into what you call sigma c. So here the as you know the what we call the Young's modulus of steel is 25 times of concrete. So here I have just substitute the in the place of es 15 ec. So in the place of es 15 ec, so es ec will be cancelled. So ultimately the sigma s is equal to 15 ec. So sigma s is equal to 15 ec. So this value is required for calculating the what we call different loads. So here and the the next property is the total load is equal to load share by steel plus load share by concrete. So here P is equal to P1 plus P2. Substitute, we have already given the value of total compressive load carried by the column is nothing but the 300 kilonewton. So 300 kilonewtons I have converted into newtons. So into 10 to the power 3, that is 1000. So here P1 can be written as, that is sigma s into what we call area as, that is the stress induced in steel equal to cross section area of steel plus EC means stress induced in concrete into area of concrete. So here ES value we have already calculated. As you can see from here, ES value we have already calculated. So we'll just substitute here 15 EC into 0 point, and area is already calculated in the above first in the second steps only. So 0.0785. Similarly EC we will keep it as usual, EC into, and the area we already know these ones. So from here what I did, I just I have took EC as a common. So EC into 15 into 0.0785 plus 0.15 1521. So B if you multiply this one and add, then and as it is in form of multiply, so if we'll take this place this side, then it will come in the form of divide. So EC is equal to 300 into 10 to the power 3 divided by 0.26985, this one value will come out from resolving these equations. So finally we will get the what you call stress induced in concrete, that is these ones Newton per meter square. Either you can keep this value in this form only. If you need to change, then what I did, I have just converted these ones into mega newtons, right? So as you know, 1 Newton 1 mega 1 Newton is equal to 1 Newton is equal to 10 to the power minus 6, right? Minus 6 means 1 mega Newton is equal to 10 to the power 6. So what I did, I just keep divide by this ones by 10 to the power 6. So 1.11 mega Newton per meter square. So you can keep this value in this form also. There is no problem at all. So it's totally depend upon you. Similarly, we will if you know the value of EC, then and if you need to calculate the compressive stress induced in the steel bars, so as you know ES is equal to 15 EC, as what you call from the above equation we have already calculated. So we'll just substitute the value. So 16.65 mega Newton per meter square is the stress induced in what you call steel. Similarly here we will carry we will calculate the load carried by it each sections, right? That is what you call steel and concrete. So here we will first calculate the load carried by steels. So load carried by steel formula is what you call stress stress induced in steel into area of steel. So we have already these two value. We can calculate this one, that is 130 kilonewtons. Finally it is in mega newtons because all the units are in mega newtons. So mega newtons into what you call thousands, so it will come in kilonewtons. Similarly, load carried by steels, we have already value of what you call EC into AC. So from here we will know the value of PC, that is the load carried by concrete. So this is the solutions of above given problem, and it is very easy. If in any types of problems of the composite sections, you can just follow these procedures, you can solve it very clearly. So let's see one more numerical so that you can build up your knowledge. Here the problem is of same category, right? And you need to follow the same procedures, that is the properties which I have explained, that is the total load and the same strength. You just have to remember these two concepts and you can solve any types of numerical. So see here, a steel rod, right, 3 centimeter diameter is enclosed centrally in the hollow copper tube. Here what happens, that the 3 centimeter diameter rod is placed in the copper hollow, right? Of external diameter of the copper is 5 and the internal diameter is 4, and we have substituted the 3 centimeter dia of steels in that one. So composite bar is then subjected to the axial pull of 45,000 newtons, and the length of the each section, that is the length of the composite sections, is given 15 centimeters. So now we have to determine the stress and the load carry, right? Here where the what you call E value for the steel and E value for the copper is given. So as you can show in the figures, that is if it is steel, right, if it is steel, if it is right, if it is fixed in one end, and if it is the what you call copper column, then the copper column external diameter is 5, as you can see 5, and the internal diameter from here to here is 4. Similarly in that one what we did, we just substitute a steel rod of 3 centimeter diameter, as you can see 3 centimeter diameter. So here we have to calculate, and the total load carried by these ones is 45,000 newtons. So here we need to calculate how much stress induced in the coppers and the steels at the same time, means how much load is carried by the steel and how much load is carried by the copper. So we just need to follow the same procedure. We have to calculate the area of a steel. We write area of a steels, right, as is 30 means 3 means what you call 3 centimeters. So I have converted it into mm. So this one is the area of steel. Similarly, means vertical, we need to calculate the area of what, copper. So here what happens, external and internal diameter is given. So external diameter is 50 mm, internal diameter is 40 mm. So area of hollow copper is equal to pi by 4, means capital D square minus small d squares. So it will come this much. Now we have calculated the area. So Young's modulus of the different materials is given, right? And similarly now we will, means as you know, that is the strain in each section is equals. So strain is means sigma s by means es, this equal to sigma c by ec. Here the sigma c is nothing but the stress induced in what you call copper, and the means Young's modulus value of copper. So I have told you that either you can take in the form of es or ec, it's depend upon you. So I will take in the form of es. So es, if you need to find the value of es, so I will means keep this value to this side. So means e, if it is in divide form, then means of course it will go in multiply form. So if it is means if it is in this form, so if I will substitute this value es by ec and this one multiply by ec, so means I will substitute this value into es. So now we can means here the different value of es and ec is given in the means question itself. So ec, that is means stress induced in copper, is equal to 1.9096, that is stress induced in steel, right, s, here it will be s. So stress induced in steel is equal to 1.9096, that is means vertical copper. So we have already means converted the means vertical strain in 1 unit. So as you know, the composite bar analysis, P is equal to PS plus PC. So means PS can be written as ES into AS plus EC into AC. So we will substitute this value means as usual, means what we did in the means first numericals, and from there we will calculate the value of EC. So if once you know the value of EC, we will substitute in the means in the form of that one ES. So once you know the value of EC, then we can easily know the value of ES. We have to substitute just the value of means EC in that one equations. So if you know these ones, just means we need to calculate the load. Then we know the load carried by the means vertical steel is equal to means stress induced in steel into area of steel. So we will get the load. Similarly, means if you need to calculate the load, then you can means either we can means this ones 45 is the total load. So if you means subtract the total load into the load carried by steel, then ultimately you will get the load carried by means vertical coppers, or else you can go through that one's sigma c into AC. Both means both equations gives the means give the same value, so no need to worry. So this is the concept related to what you call composite bar. If you really like my video, please don't forget to share, subscribe, means please don't forget to share it to your friends and subscribe my channel, so that you will get the more video. And if you have any doubt, please don't forget to put your valuable comment in the comment sections, so that means I can means what you call resolve your doubt. And if you have means any doubt or any means numerical means doubt, so you can contact us in the above given links, in means above given WhatsApp links directly. So thank you for watching our video, means see you in the next video. Thank you, take care yourself.